Okay, so for today we have using proportional relationships in my geometry class. So a couple things we're going to do. Okay, for this first one right here, I'm going to set up a proportional using similar triangles. Now, finding an unknown height. How tall is a tree? So I'm going to plug in some values for this one right here to actually show how to do this. So I'm going to draw this person. I'm going to say this person is annoying and spits on people. This person is, I'm going to give this person credit. Let's say 6 feet. 6 feet tall. This person is 6 feet tall. And at this current time of the day that we're doing this problem right here, is casting a 9-foot long shadow. Okay, later in the day, the shadows get longer, right? When it's directly at noon, you basically have no shadow. If the sun is directly overhead, it's only pointing straight down, so you really don't have much shadow there. So from this, I'm going to find some unknown value. So what I'm going to do here is I'm going to say, and I'm taking this information from down here, tree shadow is 21 feet long. So what am I going to put right here? 21 feet. Okay. And how tall is the tree? So, no, it's not. So right here, it says how tall a tree if you are 6 feet tall. Our annoying person that throws stuff is 6 foot and has a 9-foot shadow. I got this from right here. So, do we know how tall a tree is? No. Say no. No. In math, what do I represent I don't know? I'm going to put a variable. I'm going to call that x. Okay? So that's going to be my unknown value here. So from this one right here, let's see. So I don't have color here, so it makes it even worse. So blue line segment represents the ray of sunlight. This thing right here. There you go. What kind of triangle is formed by the tree and the shadow and the ray of sunlight? What type of triangle is that? Right. Very good. Whenever we're dealing with the shadow problem, we're always going to be dealing with a right triangle. So I know that I could draw a little box in here, if you guys could see that. Little box indicated that that's going to be a right triangle. So I'm going to put a right triangle here. You know what? I'm okay with that comment. It's not negative. Suppose the sun is shining and you are standing near the tree but out of its shadow, kind of like here. You will cast the shadow as well. The rays of the sun are parallel, so this and this go together. The rays of the sun will be parallel if you do this at exactly the same time. Same time, you're going to have similar because the shadow length are going to be proportional for this. Okay? What do you know about the two triangles formed? Okay? I know because of this, I have, these are going to be parallel. These two are going to be similar to each other. So they're going to be similar right triangles. So I'm going to have similar right triangles here. Okay. So now, I have my information that I pulled from down here. Tree shadow is 21 feet. Your shadow is 9 feet. How tall is the tree? I don't know. You are 6 feet. There we go. So, I have now set up some similar right triangles. Now, let's set up a proportions. When we do the proportions, we start with corresponding sides. The sides that go together the sides that go together on this problem right here, let's say sides that I know. I know right here that 21 goes with which one? 9. So I'm going to start with those. Start with ones that you know. So I know that these two sides correspond. So I'm going to start my thing with 21 over 9. So I started with the big triangle over the little triangle here. So big triangle over little triangle. Now that's going to be equal to, because it's similar, what goes on top of the next part right here? X over 6, very good. X over 6. Those are my next pair of corresponding sides. X over 6. I do my cross products, and I get 9 times x is 9x equals 21 times 6. You guys have that little 126, very good. Okay, you guys got a calculator. Everyone has a calculator, as long as you're not over there playing with your phone right now, right? So, what would I do to try and get x by itself? Divide by 9. Very good. So, x is going to be equal to, very good, 14. What are my units here? Feet. Very good. Now, the units go together. So, my similar right triangles would be the same if this was in meters and this was in feet. Okay, the similarity still works out, but if this one over here is in meters, that means the unknown value I have has to also be in meters. Okay, we could compare different units, but same units over here and same units over here. Now, right here, it's called indirect measurement. It's a method of using proportions to find an unknown length or distance in similar figures. Sid, the science kid, is 72 inches tall. To measure a flagpole, so this one right here would be my Sid, right? Sid stands near it. Right here, standing near it, to get the similar, right? Because of the shadow that it casts. Sid's friend Miranda measures the length of Sid's shadow and the flagpole shadow. 48 inches and 128 inches. So they're the same units here. Find the height h of the flagpole. So how would I set up this problem? Start with what I know. What do I know? Okay, which ones? Let's start with corresponding that I know. Which corresponding that I know? I know the 48 and the 128, right? These two sides correspond together, right? They correspond. They're the same side of similar triangles, so these are corresponding, and I know both values. That helps out. So I'm going to start with 48 over 128. And that's going to be equal to 72 over h, right? Because 48 was on top of this ratio, right? Which came from the small triangle. And then h is from this triangle, so it's going to be 72 over h. And from here, I'm going to go through and do my cross products. So I get 48h. What is it? 9216, like that?
Yeah.
Okay, good. Now, to get h by itself, I need to do what to both sides? Divide both sides by 48. Very good. Divide both sides by 48. H is what? 192 inches, right? That's kind of what I needed there. All right, so let's take a look at the next problem here. Okay, finding an unknown distance here. Real world situation, you may not be able to measure an object directly because of physical barriers. Example 2, Julie and Carl want to measure distance d across the Grand Canyon at its narrowest point. They locate the point as shown in the figure. Why will these triangles help find the distance? Okay. Are we saying that these are going to be right triangles? Say yes.
Yes.
Okay, so if they're right triangles, I'm going to put a right here, and I'm going to put a right here. Now, this is something that you have to recall. Do I have another pair of angles that are going to be similar? That are going to be congruent, I'm sorry. Do I have another pair of angles here that will be congruent?
Yes.
Yes, and I know I don't have anyone sleeping right now or trying to sleep right now. Thank you, right? So, for this right here, what shape does that make? X, so that's going to give me vertical angles. I need that. So if those are vertical angles, I know that that one is congruent to that one. Now, because of that, those two triangles are going to be similar. These two triangles are going to be similar by how? I heard it, angle, angle, right? They're going to be similar by angle, angle. That's going to help me out. So I know to find the distance that I'm going to have similar right triangles.
Is it always going to be similar right triangles because it's a shadow?
Yep. Yep, this is going to be like this. It's always going to do that. All right, so now let's go through and try to find the value of D here. So let's go ahead and set up my problem. Okay, I'm going to set up my problem here. Start with what I know. What corresponding sides do I know?
Wouldn't it be 450 and 6?
Very good. 450 and 675, right? Those two sides are corresponding. They're going together, right? Those correspond to each other. 400 going this way will go with D over here, right?
Yeah.
So start with what I know. So I'm going to say 450 over 675 is equal to over D. Very good. So please, everyone, right now, I would like for you to solve for D. Right now. Right now, and I know no one has their head down at this current moment right now. I don't have anyone that would do any of that. No one's like that in here. Give me a minute. Let everyone actually work on it. All right, so let's see. We come up with class. What do we come up with? 600 feet. Very good. So 600 feet. Make sure this is another unit in which that you always have to have your units. Even if there is no units measured, what would you write? U, right? U, or whatever units. We're going to get into doing some similarities using areas and volumes, and those units are cubic and square. Okay, so I need to actually pay close attention to that. All right, so let's take a look. You guys have practice for today, which is going to be on 20. All right, so don't forget, like and subscribe.